Hello. Yeah, I think it works now. Okay, so microphone should be working right now. Let me get started then. Okay, hello everybody. Today's topic is to create a geometry called Spirallohedron, which was initially founded by a Russell Towle while he was finding a geometry based on the Rhombic shapes. And he found out that this kind of spiral shapes made with rhombic geometry could be packed if it has 3 faces like these or 4 faces like these. You can pack it in the 3D space without any gaps. Now other geometries like 6 faces or more than that cannot be packed entirely, but can be tiled with some gaps. So it still is an interesting geometry. And I am going to create a procedural 3D model of this kind of spirallohedron, and with the feature that those spirallohedron with 3 faces or 4 faces could be packed in a 3D space without a gap, so can be used for space filling geometry. Now I am not going to use this rhombic as a basic geometry, but I am going to instead use a minimal surface in order to create this kind of smooth surface for the sides, for the faces. Okay, and I have put some reference for this geometry on the description of the video. If you look at the description, I have pasted some links to the papers which explains some of the characters, some of the features of this geometry. Like these. This one explains how the geometry could be packed in 3D based on the 2D orientations. So these are really informative. And I am going to use some of the algorithm or equations shown in here. Mostly what I'm going to use is this one, Spirallohedra space filling attribute to Russell Towle. And at the end of the page, page 7, there's some equations how you can create the base of the spirallohedron. So I am going to use some of the equations written here to actually create it in Houdini. Now, just to show you the result, this is gonna be the shape that I'm gonna make today, and you can download the same files from the GitHub URL from the video description as well. So if you're interested, you can download it and open it in your Houdini. I made it in Houdini 18, so I think you can open it if you're using version 18. Right, so I have parameters like side of the face of this spirallohedron, these. And if the side is 3 or 4, I made it possible to pack it or tile it on the grid. So if the size is 4, if you increase the number of tiles on X direction or the Y direction, or the z direction, you can pack it like this and without any gaps, like this. So it's pretty interesting to see that this kind of a complex shape could be packed in a 3D like this. And also same for the type 3, side 3, you can also pack it like this. And other than that, like 5 or 6, you cannot pack it, so I'm leaving as one shape. But it can be laid out. Some of the faces can be attached to each other for like a hexagonal shape like these. It does have some gaps, but it's interesting to see that these shapes can be tiled in 2D or 3D. And you can also change the radius of the shape or the height individually. So these are the stuff that I'm gonna implement today. Okay, now let's get going. Now, first thing, let's look at the information paper, how I should start. Now, it says that the cylinder of revolution radius r and h, so we have the radius parameter and the height parameter here, and with the center axis passing through points r00 and r0h. So let's start making those first. Right, so I should be starting from a line. Let's create a geometry first on Houdini, then create a line. Then I'll set the number of points to some high number like 50 so that I can make it like a curve later on. And facing directing upward is okay for now. I'm going to use the point rectangle for this line to control each point's position based on the number of the point from 0 to 50 currently, right? So let's say base spiral curve. Okay, now first of all, let's create a parameter called radius. So float radius equal to radius, and promote it like this, and then also create a parameter called height, called height, right? Let's also make a null controller to have all the parameters that I'm gonna use today. So name this controller and have the parameter radius and the height as well for this one. So radius maybe the range from 0 to 10 is okay, or maybe 5. And also the height, zero to 10. Okay, and let's also copy this parameter to this promoted parameter channel. I'm gonna rename this to height, right? Okay, now let's make some basic spiral curve based on the information here. So, which is written here, x equals to radius times 1 minus cosine t, y equal minus r times sine t, z equal t times h divided by 2 pi. And the t is the information is the angle between 0 to 2 pi based on the point position from bottom to top. So, okay, let's keep this on the left and write some code based on this information. So, first of all, let's calculate the t. Let's create the value t, angle t. So based on the point number divided by the full number of points for this primitive, so n points. Now I do need to subdivide it by 1 because the point number starts from 0. Right, then multiply it by 2 times pi so that the t will be 0 to 2 pi based on the point position. Right, so now that I have t, let's replace the x coordinate of this point, this line, using this equations r times 1 minus cosine. So radius times 1 minus cosine t, and okay, oh, I think I got the delivery. Could you guys wait a little bit? Sorry. Sorry, that was the delivery from Amazon. Actually, I go glossaries. Yeah, these days. Sorry. Now, now I have made a X. Now, is this changing anything? Doesn't seem to. Okay, let's check the value here. Go to the geometry spreadsheet. Now X is not changing, so I guess something is wrong here. I guess I gotta make this division, the num points and points to float number, because currently it is defined as an integer, which makes this division always 0, I guess. So just make it float. Now something happens. Right, it's really, the radius seems really high right now, but it's okay. I'm gonna update other value as well. So for y, it's minus r times sine. In Houdini, the plane axis, the plane information is x, z, and the above upward direction is y. So in this case, I'm going to use z instead of y. So minus radius times sine t. Okay, now I seem to have some spiral curve with these information. And finally, z equal th divided by 2 pi. In this case, I am going to update the y value. So t times height divided by and 2 times pi. Okay, now I think I got the basic shape here. Now let's see if the shape will change based on these parameters. So when the height is 2 and the radius is 1, yeah, it seems correct, but I'm guessing that the radius or the height, maybe the radius is a bit too high if the radius is 1, but if I see it here, the radius of this spiral itself is 1, but for overall shape, the radius is becoming 2, so I want to make this parameter for the radius for the whole shape. So I am going to multiply the promoted radius parameter here by 0.5 so that it will become the half the radius that I have promoted from this overall radius parameter. Okay, so this looks good for initial spiral curve. Now I want to have another parameter, which is the number of sides. In this case, in this paper, it is called k. So let's create that. Now I don't think I need to read the paper anymore. So let's first go to the controller's parameter interface and then make an integer parameter called a size. Indicate the number of side, maybe starting from 3 to something like 7 or 10, anything. If you make the number of sides high, then the geometry will become more smoother and smoother. The side will become smoother and smoother. Right, then let's start with this 3 and copy this parameter to... Now what I want to do next is based on the side number of the sides parameter here, I want to just make one side first as a surface, as a mesh, then rotate it. If the number of sides is 3, then rotate it by 120 degrees for 3 times to make it 360 degrees to fill in, to create the shape, to complete the shape, complete one shape. So in order to create one shape, one side, I am going to use the transform to rotate this curve by 120 degrees if the number of side is 3. So which is calculated by 360 divided by the number of sides. So let's copy this parameter and then go to the transform. Then for the rotate y value here, I am going to make an expression which is 360 divided by copy paste relative references to divided by the number of size, which will become 120 in this case. Right, so now I have one curve and another curve here, which will be the outline of one face of the spirallohedron. So let's merge this together to make it like a continuous curve here, but I still have two primitives inside this merge node. Now, in order to create a surface in between these outline curves, if I look at the image which should be created, it looks like this kind of smooth surface, smooth twisted surface. And in order to create that easily without using a rhombic, what my method here is to use a minimal surface, create a minimal surface out of this outline. And I have also created a small video about how to create a minimal surface in another video, so if you want to know it, you can check it out. But I'm gonna do the same thing here. So first I am going to use a polyloft in order to create a continuous plane which goes from the one curve to another curve. But currently, as you can see, the surface itself is not smoothed. It's just a straight lofted geometry which doesn't look the same as this one. So in order to make it like twisted surface with a curvature, which have a curvature like this, which means you have mean curvature of 0, the easiest way I found out is to first let's reverse this geometry so that the normal will face outward like this, the white plane will face outward, and then I'm going to use the for each loop, like for each number, to iteratively smooth this out, smooth the surface out to make it like a minimum surface. Now I just need two components inside. One, before that, I have to set the gather method for the for each end to feedback each iterations, and then for the for each begin, I'm gonna set it to fetch feedback so that the loop become the feedback loop. Then first I need to use the remesh to smooth this surface out. Remesh this surface out using some target size here. So I'm gonna set the size to more smaller the value is for this target size, then you should have more precise surface. But I'm gonna set it to 0.1, and let's iterations maybe 3. And after that, I am going to use a attribute blur, and this attribute blur will have a smooth function called Laplacian here, so I'm going to use that one in order to smoothen out each point's position based on the neighbors. Set the step size to 1 and blurring iterations to a really high number like 100. And also set the method to edge lengths to make it more precise. Right, then doing this over and over again, like in this case 10 times, you can make a kind of a similar surface to this one made of rhombic faces, but it still have the same features. You can also use this to pack geometries if the number of sides is 3 or 4. I've checked it before, so I think it's correct. And yeah, if you increase the number of iterations here, you can also make it smoother and smoother, but yeah, as you can see, it doesn't really make any changes from 10 to 100, so I'm gonna keep it to 10. I think it's fine. Right, so now that I got a base for the one surface, I just need to rotate this 3 times if the number of sides is 3, so that is easy. I'm gonna use another for each loop for each number. And then in this case, I'm gonna set it to merge as it is, and then I have to set the iterations to 3 if the number of sides is 3. So just gonna copy this parameter size from the null controller and copy, then paste it here. Now I am doing 3 loops here. Now for each loop I need to rotate this face by 120 degrees or 360 degrees divided by a number of size. So I'm gonna make a transform here. And then for the rotation, this will be 360 degrees divided by a number of sizes and times the number of iterations, the current number of iterations for this loop, which can be retrieved from this for each count 2 and from the detail attribute. Yeah, this one, iteration. So I'm gonna get this iteration attribute using expression on this transform node. So I can get that by calling detail function, detail, and from the node called for each count 2. And the number of name of the attribute is called iterations. Iteration, and I'm getting the first value here, because there's only one value here. Okay, so that is the expression, and as a result, you'll have 3 faces rotated to create one completed shape. Now, this is pretty much it in order to create one single rhombic. Well, this is not rhombic, so one single spirallohedron shape. So as you can see, you can already change some parameters. Let's hide the edges. You can change the number of sides here, or the radius, or the height. Now, stopping here is not that interesting, as you can see. So I want to also make it able to pack this in 3D space, fill the 3D space with some of the shapes here, which in this case you can pack this geometry with the size of 3 or the size of 4. So I'm gonna start with the size of 4 to pack this in a 3D space. Now, before doing that, let's check that by creating a grid, which create this kind of grid plane here, and delete the primitive and keep only the points by checking the pattern to star and check the key points. Now I got only the points here. Let's set the background to dark. And I am going to use a component called copy to points in order to place this one rhombic geometry. Currently the side is 4 to these points. As you can see, it's not packed. I mean, some of the geometry is intersecting. So let's try to change some rows and columns to see what seems to be the right size here. Now this is how I found out the right size here. I am going to use some equations later on in order to pack it in a correct number. But as you can see currently, that this doesn't seem correct. Even if I change the size of the square grid, it doesn't seem to pack. So when I rotate this grid in with 45 degrees, now something seems to happen. If, as you can see, if you look from the top, it does seem to pack at some point like this, with the clean edge attaching to each other in 2D. Now this seems right. So first I'm going to keep the grid rotation to 45 degrees. Then the next thing I have to define the size of the grid. And that can be calculated by some of the function using trigonometry, which I have found before, but let's start by setting the parameter pretty easily and pretty uniform value. Like, let's keep the radius to 1 and height to 2 to make it simple to check. I will be able to control this later on, but I'm gonna keep with 1 first. Then let's set the size. Let's keep the rows and column to 2 to make it more simple. And then set the size to see what seems to be the right size. Like around here. And that is 1.4, around 1.4 something. And which is kind of similar to if you are aware of trigonometry, if you did use trigonometry a lot before, then you might have seen this before. That you can calculate it. The same value could be retrieved by, let me draw a sketch here. So if the size of the grid, if the size of the square is 1 and 1, then, and if you want to know the diagonal lengths here, the x equals to, let's say this is a and a. The x equals to a times plus a times a power of a and square of a and square of a. Add it and use the square root. So that is square root of 2a square. And if the a equals to 1, then the x is around 1.4 something. So the value here should be related to that kind of stuff. So let's copy this radius value here and paste it here. And first of all, let's create a square by using a power, and then multiply by 2. Then use a square root, and as a result I have a value something similar to 1.412, which is similar to this. So let's copy this expression and paste it to the size of y here as well. And as a result, now that the parameter is based on the radius value, if I change the radius here, as you can see, the geometry is always following the grid, like here. Now this does still have some problem here, because if I change the rows and columns, then the layout will change again. So I need to create this size value based on the rows and columns as well. Right, so first of all, let's copy the same expression to the y, because I'm gonna make it separately. I'm gonna make the expression separately. And then let's create some parameters to indicate the number of rows, number of columns, and number of heights. Z value, I mean the y value. So for that I'm going to use the integer. Just gonna name this nx, range from 1 to 10, and duplicate this parameter 2 times. Now the next one, and y, and y, and for the last one, and z, right, apply. Okay, let's set some random parameter here and copy this nx parameter and paste it, where was it, this, to the rows. And wait, nx should be columns, sorry, and nz should be rows in this case. So if I set it to 1, I have only 1. Then if I set nx and nz, I have 2. Now if I make the value nx and nz more than 2, then this ought to have some problem here. So I need to use these rows and columns parameter to the size to make it make the size bigger based on the number of rows and columns, right? So let's set it to simple. If the size of 1, then the size of the grid should be 0, I think. And if the size of the rows and columns is 2, then the size should be, let's set the radius to 1. The size should be 1.4 times 1. But then if the nx and nz is 3, then the size of the grid should be 1.41 times 2. So that is based on the columns and number of columns and rows. I can copy this parameter, and for the x, I can multiply it by a number of columns, but subtract it by -1, so that if the number of columns is 3, then multiply it by 2, like this. Same for the rows, copy this parameter, and for the y, multiply it by a number of rows, subdivided by -1. Now I seem to have a correct grid value, and the edge is touching smoothly. And if I change the number of grid here, it does seem to have a correct layout here. Great. Right? So that is for the x and y, x and z in this case. Now I also want to do pack it on the y direction, which is the upward direction in this case. Now let's try out manually by using transform to see what kind of value I need to use in order to create a packing in a z direction. So I'm gonna just use a transform and merge with the points, original points with the moved points for the point array, point to copy to points node, and I'm just gonna translate the copied points to upward. And as you can see, this doesn't seem to pack well, even if I change to any numbers to the to the y direction. So I think I also need to change the translate value for the x and y as well. So I think I need to move it to x direction and the y direction to the z direction as well in order to pack it. It's a bit hard to see here, but yeah, this doesn't seems clear, but maybe around here. It's not really entirely correct places, but if I look at the result of the points, the current point position, I can see that the upward grid points is in between the center of, inside of center of each squares on the bottom square grid. So that seems to be straightforward. I just need to move this point, this upper points to, so that each point will come to the center of the bottom grid square point. So let's do that. Now, in order to move points to the center, it might be easier to do that without doing the rotation. So I'm gonna reset the rotation to 0 for now. And then let's delete those and use a transform node, as well as having a for each number node, for each number component, to lay out this point on a y direction with the specific number of points on, which is this one, ny. So I'm gonna copy this ny value here, which is the number of height direction, number of grid on a height direction, and paste it in the iterations here. Right. Now let's set the parameter to some random value like 3 or 4, and place this transform in between the for each node. Now for each steps, I need to move the geometry to the upper direction, and that is by the value that should be related to the number of the value of height, which I've set it here. So let's copy this parameter and then paste it here to the y value of the transform direction. Let's paste this, paste relative reference, and then also I need to multiply this height value by the number of iterations for the loop. So as I did before, I'm gonna use the detail function to call the detail wrangle from detail attribute from the for each count 3 named iteration first number. And let's look at the result now. That seems to be correct. Now I also need to move the even number of point, which is on the even number of the height grid, to shift it the half size of this grid size, to the right and to go backward or forward, meaning I have to shift this points which is on the even number to the half size of the grid to the x direction and half size of the grid to the z direction. So do I already have the value for the size of the grid here? I think I have, which is this value here, this one. So I'm just gonna copy this expression. This should be the size of the grid from point to point. So I'm gonna copy this parameter, then paste it to the x translate parameter, and then multiply by 0.5 so that I can shift it just by half size. Do the same for the z. Now the problem here, as you can see, that all the points has been shifted right now, so I only need to shift for the even number points. So for that I can use a modular. So for the iteration value here, so if the iteration is even number, then move it forward, shift it, and if not, then don't move it, or vice versa. Now to do that, I'm going to use the multiply and then get the iterations again for each count 3 named iteration. Now it's been a long expression here. That's what I don't like about expression, because it's tend to become really long. Okay, so now I had these iterations, and what I want to do is to make modular calculation by 2. And by doing that, I can shift the even number or odd number by this size. Now do the same. Now I'm just gonna copy this and paste it to the z. Do the same for the z to shift it on z direction. I think that this seems good enough. Okay, now replace this copy to points for the template, but there seems to be some gap here for the height direction, so I guess I need to multiply this height value by some value here, and I guess this is a half size. If I do that, now I seem to have a clearly this. Okay, yeah, I still need to do some last stuff because I just canceled the rotation by 45 degrees last time, so I need to do that again, do that on the last in order to make it like a correct alignment. So do the 45-degree rotation for the y axis, and then if I look at it, I seem to have a space-filled geometry without any gaps in between. And I found it really interesting that, I mean, currently it's just a packed geometry, but if you change this, if you change each geometry, if you replace each geometry with more, I don't know, designed stuff like traced geometry, then maybe you could create a new kind of structures, probably. Maybe I can show you that later on. Now, this layout, which I have just made, doesn't work for when the side is 3 or other than 4. So if I change the number of sides here to 3, then obviously the packing wouldn't work anymore. If I set it to 5 or 6, doesn't work. So it only works on 4 for this grid. So let's make a switch node so that the output, this grid output, will only appear when the side is 4. So I'm going to connect the single Spirallohedron geometry to the first input for the switch, and then second for the layouted packed geometry for the side 4. Then make an expression here on the select input saying if this number of sides here, let's copy this, is equal to 4, then output this one. If not, then output the original single shape. So if this number of sides copied from the parameter is equal to 4, then output 4. But if the number of sides is 3 or 5 or 6 or 7, then just output the single geometry like this. Now I guess I can do the same thing for the triangle, and it's a bit more complex, so I would recommend you to look at the file that I have uploaded. I guess it's not really doesn't really make sense to do it from scratch here because it's just a triangle grid, but I'm just gonna show you what it looks like. I'm just gonna copy the code from the last file that I created and create an attribute detail, attribute wrangle to create a triangle grid. And let's set it to detail. Let's copy some code, paste some code copied from the file that I have uploaded. This is to create a triangle grid for the X, Y, and Z, and also have some parameter here which should be linked from the main null controller. So let's do that first. Let's copy the radius, and then paste it here. Rename this to height, rename this to nx, rename this to ny, and then c here. Okay, everything should be copied correctly. Now if I look at this triangle grid, let's set the ny to 1 or nz to 1. So I have a grid like this, triangle grid, which is a simple triangle grid using 60 degrees restrictions for each triangles. And then for the height, when you create a grid on the height direction, if I just create one more, then it will start to create this kind of hexagonal grid. Start having a hexagonal grid. I mean, it's just a combination of triangle on the top and bottom, but by creating on the top, by shifting it to create a hexagonal grid like this, I'll be able to pack this Spirallohedron when the number of side is 3, like this, filling the space without the gap, like I did for the number of sides is equal to 4. So please check the code written inside here. Not much special things happening here. It's just a code to create a triangle grid here, and the value, the method I found the correct value for the spacing is pretty much the same as for the squares. I just tried from the manually using transform to move it x and y and z manually to see what seems to be the best value in order to create the packed grid. And I have just transformed it into more sophisticated equations, like using trigonometry or some simple equations. So keep that in mind, and I'm going to create another switch node because this one only works for side 4 currently. So I'm gonna apply another switch here, so the base geometry, base input, single geometry comes to the first input here, then the second input, base geometry should come from here, and then the triangle grid should come. I think I need to just make another copy to points here, then apply this, connect it to the second input of the second switch. Then let's copy this expression from the first switch to the second switch and just replace the number 4 to 3. Right, now let's try if I get the right value here. So currently the number of sides is 3, and I'm getting the space filling geometry when the size is 3, and if I set it to 4, I have the space filling geometry when the size is 4. Then for the 5, 6, 7, I just got the single spirallohedron. Alright, so this is pretty much it. Let me just, as a last point, the one that I'm gonna do now is not related to a spirallohedron itself. It's just one types of usage what this could be used for, what I thought of. Maybe since I am working in kind of a maker field, making physical stuff out of a 3D model, so since I am kind of in an architectural product design field, so let me convert this into some kind of truss structures so that I can make it as an interesting structure. To do that, from this rhombic basic shape, I'm going to make a truss shape out of this one with the simple step. Now, first thing, I'm going to create the divide node to melt down every inner curves which I have for each faces by checking the remove shared edges. And after that, I just want to retrieve the outline. So I'm going to use the primitive node here, and then just go to the face hull tov, check close U with the unroll shared point, and I have this outline extracted. And let's also check the points here. Now after this, I'm going to fuse this because some of the points has been duplicated at the same position. Then I might want to resample this in order to make it more high res. Let's check this resample by polygon edge, and then set the length, or maybe set the maximum segment instead to, I don't know, 100. Or maybe that is too high. Maybe I'll just set the maximum segment length to 0.05 or something. Right. Then after this, I'm going to use a BDB from particle node to create a tube-like shape from these points. Set the point radius scale to something like 0.2, maybe based on the radius. So I'm gonna copy this radius value here and then paste it to the point radius scale, multiply by 0.2 or something. Yeah, and also do the same for voxel size, maybe a half size is okay. And then convert this BDB into a polygon. This. And let's create a intersected geometry with this shape. Now use the boolean, set its input to first input, and set the converted BDB to the second input, and I'm gonna set the operation to intersect to create this kind of truss shape. Maybe I wanna make the thickness a bit more higher, maybe 2.5. Right, that looks good. Now, by replacing this base geometry instead of this one to the newly created this one, by maybe I'm gonna use another switch node. So first one here, the second one here, then replace the geometry here with this one as well. Right? And if I check the switch input to 1, I have this kind of packed geometry, which I don't see this kind of truss that much. So I think it's one of our interesting usage. So just by converting a single spirallohedron to another shape based on keeping the base as it is, but making just a hole makes a really interesting geometrical structures like these. And if I change the size to 3, the rule is the same, so you can still see the packed geometry with these each spirallohedron having a hole like this, making really interesting structures. Okay, so that could be one of practical application you could think of using this kind of space filling spirallohedron geometry. Maybe you can think of other things, other interesting things. If you do, I would really like to know that. So this is pretty much it for today's live. Thank you for watching. I have a comment. Bought your book, but you make a lot of guessing in the book. Yeah, I guess so. I mean, a lot of stuff I start from the guessing and then find out the correct equations after trying out manually. That's kind of my method since I'm not really good at mathematics initially. So that's kind of my way to work. Okay, thank you for watching. If you have any questions, I'm really happy to answer it. If not, this is it for today. It was kind of a rather easy geometry, but I hope you find it interesting. I think I'm gonna do another kind of live next week, probably in Japanese next week. If you could, if you're interested, I'll be happy to have you guys. Okay, so as I said, the files that I have made it here is posted on a GitHub. You can download the file from the link in the description. You can also, I have also attached a link to the reference that I use for this geometry, reference papers. You can also check that. If no questions, and I am going to end this live for today. Okay, thank you very much. I'll see you next week, hopefully.